Okay, so in this video, I want to go over the solutions for the final exam practice. So final exam practice solutions. Okay, so and remember this is this is on the final exam is going to be on the entire semester, right? So we start right back in chapter 1. So the first question here, they just wanted you to add fractions together. So 3/4 plus a negative 5/12. So remember, in order to add or subtract fractions, right, we have to have the same denominator. And I'm adding two numbers that have opposite signs, right? So remember the rules for adding two numbers with opposite signs. I take the absolute value of each number. So absolute value of 3/4 was 3/4. Absolute value of negative 5/12 is positive 5/12. Now, because I need to add and subtract fractions, I better first convert them so that they both have the same denominator. So in this case, we can see that the lowest common denominator is 12, right? The lowest number that 4 and 12 will go into is 12. So I can correct this first fraction, 3/4, by multiplying by 3 over 3. So this is equivalent, 3/4 is equivalent to 9/12. And the second fraction's okay, right? I can leave it 5/12. Now remember the rule here, right? So remember, I'm adding two numbers that have opposite signs, that have different signs. So the rule is I subtract the largest, I start with the largest absolute value and I subtract the smallest absolute value. When you do that, right, 9 minus 5, you're going to get 4/12. And then that can be simplified to 1/3. But then remember the rule for figuring out the sign? It's the sign associated with the larger absolute value. Since 9/12 is larger than 5/12, and originally 9/12, which is 3/4, had a positive sign, this is going to be a positive 1/3. So the answer should be B in this case. Okay, second one, number 2, was dividing fractions. So remember, to divide fractions, the first fraction, you can keep it the same. So just rewrite it, 3/4. And then usually instead of division, what we do is we turn this into a multiplication. And that will work as long as we multiply by the reciprocal of the divisor. So we have to flip the second fraction. So this will become negative 7/6. Then you should always simplify first if you can, right? It's just easier. So it looks like 3 goes into 3 once, 3 goes into 6 twice. And now if I multiply across, right, the numerators, 1 times negative 7 is negative 7, and then 4 times 2 is 8. So it looks like our answer is negative 7/8, which is B again. Okay, 3. So let's see, I have 2 times x minus 2 minus 9, and then plus 6 times x minus 1 plus 6. Okay, so I just want to simplify this expression, right? So normally order of operations, we would do innermost parentheses first. But I can't really simplify, right, the innermost parentheses. I have x minus 2. I can't combine those, and x minus 1. So then I'd work my way out to the square brackets, right? And within those, I need to do multiplication before addition and subtraction. So I need to distribute the 2 and distribute the 6, right? Multiplying the 2, multiplying the 6. So if I do that, here I'm going to have 2 times x is 2x. 2 times negative 2 is negative 4. I still have a minus 9 there. And then here, if I distribute into 6, I have 6 times x is 6x. 6 times negative 1 is negative 6. Okay, then I should combine like terms within those parentheses. So I have 2x minus 13. And then I can remove the parentheses after that, right? So 2x minus 13 plus, and then negative 6 plus 6 is 0, so this is just plus 6x. And then finally, if I combine like terms, I'm going to get 8x, right? 2x plus 6x is 8x, and I still have a negative 13. So that would be my final answer, right, when I simplify the whole thing. So it looks like 8x minus 13, which is D. Okay, 4. Actually, let me bring up a new page here. So 4 asks us to solve the equation. So we have negative 7 k minus 7 minus negative 8k minus 6 equals 3. Okay, so first thing I would do is I would distribute in the negative 7 and distribute in the negative 1, right? So multiply by negative 7, multiply this by negative 1. So negative 7 times k is negative 7k. Negative 7 times negative 7 is positive 49. Negative 1 times negative 8k is plus 8k. Negative 1 times negative 6 is plus 6. That equals 3. Now combine like terms on the left-hand side. Well, negative 7k plus 8k, that's nice, right? That's just k, 1k, which is k. 49 plus 6 is 55. And that's got to equal 3. And then I want to solve for k, so I need to do one more thing. All I need to do is subtract 55 from both sides. So k equals, and then what's 3 minus 55? Well, that's going to be a negative 52. Right, so 4 should be A. Negative 52 is the correct answer. Okay, 5. Number 5, we're asked to solve for the variable, the indicated variable. In this case, we're given the equation A equals P times 1 plus NR. And actually, in this case, we want to solve for N. Solve for N. So first thing I would do is I would distribute in that P. So if A is equal to, well, P times 1 is just P, and then P times NR is plus P and R, right? Just write it together. Now, if I want to solve for N, I need to isolate that P and R term, so I'm going to subtract P. So now I have A minus P is equal to P and R. And now since N is being multiplied by P and R, I can simply divide by P and R, right? And whatever I do to one side, I do to the other side. So the P and the R's will cancel on that side. So I'm going to get N is equal to A minus P over PR. And in this case, that should be D is the correct answer. Okay, 6. It says 994 is, remember that's equals, what percent? X of multiplication, 797. If you want, you could write this as 797x. I'll put the variable on the left-hand side, equals 994. Now, how do I solve this? Well, I need to divide both sides by 797. Also going to grab my calculator. So divide both sides by 797. So x equals, and if you do this out, 994 divided by 797, you're going to get 1.247, so on. Actually, it says round to the nearest 1/10 of a percent. Okay, so we need to do that. We're going to need to go to 3 decimal places to begin with. So I have 1.247 2, 4, 7. Right. Now remember, if the unknown is the percentage, which it is in this case, then we have one more step to actually write it as a percentage, because our answer right now is just going to be a decimal form. So the last step is to convert this into a percent. Well, how do we convert it to a percent? You either multiply by 100, right, and then just attach a percent symbol, but that's equivalent to moving the decimal point 2 places to the right, right? So this is going to be 124.7%. And that is answer A in this case. Okay, 7. So I want to solve this inequality, right? I have negative 35r minus 35 is less than or equal to negative 5 times 6r plus 11. All right, so I remember you solve an inequality just like you would solve a regular equation. The only thing you have to remember is that if at any step, and typically it's at the end, if you ever multiply or divide by a negative value, you have to switch the sense of that inequality. Okay. Otherwise, it's just like you would solving a regular equation. So I need to distribute that negative 5 in first, right, on the right-hand side. So I have negative 35r minus 35 less than or equal to, negative 5 times 6r is negative 30r. Negative 5 times positive 11 is negative 55. Now, actually, let me bring the r's to the left-hand side. So I'll add 30r to both sides. So I'm going to get negative 5r, right? Negative 35 plus 30 is negative 5. So negative 5r minus 35. Still, I have less than or equal to negative 55. Then I'm going to add 35. So to get rid of it on the left-hand side. So I have negative 5r still less than or equal to, and then this is going to be what, negative 20. But then in this step, where to get r by itself, I have to divide by negative 5. Here's where I have to switch that inequality, the sense of it, from less than or equal to, it has to now become greater than or equal to. And then negative 20 over negative 5 is a positive 4. So it should be r is greater than or equal to 4, which is C. Okay, great. Graph the line containing the pair of points and find the slope. Okay, so they give us, this is question 8. They give us the points 1, 3, and 0, 0. Okay, so let's calculate the slope first. So label these, right? x1, y1, x2, y2. Remember the slope we can compute as y2 minus y1, right? The change in the y, or change in the output, over x2 minus x1, over the change in the input. So this is going to be 0 minus 3 over 0 minus 1. Well, that's going to be negative 3 over negative 1, which is just a positive 3. So the slope is a positive 3. And then to graph it, just plot those 2 points, right? So we have our Cartesian coordinate system. So x, y. I want to plot the point 0, 0. That's right here, right? And then 1, 3. So I move 1 to the right, up 3. And then the line that passes through those is going to look like this. So in this case, it looks like C is the correct answer. So it should be C. Okay, 9. You're given an inequality in 2 variables. So x minus y is less than or equal to negative 8. And we want to determine whether this point, negative 2, 3, is a solution to that inequality. In other words, does it lie within the shaded region? Well, we don't even have to graph this to figure this out. All you have to do is plug it in, right? And see if you get a true or false statement. So negative 2 is our x, y is 3. So if I plug it in, where I have an x, I plug in negative 2. Where I have a y, I plug in 3. I'll put a question mark here because we're really checking it. So what's negative 2 minus 3? Well, that is negative 5. And so now we're asking ourselves, is negative 5 less than or equal to negative 8? No, right? It's greater than negative 8. So this is false. So therefore, is that point a solution to that inequality? No. So I'll say not a solution. If we plugged it in and we got a true statement, then we say, yes, it is a solution. In this case, we got false. So it's not a solution. Okay, 10. So we want to graph the inequality. Okay. So x plus 4y is greater than or equal to 5. All right, so here's my Cartesian coordinate system. X, Y. All right, so remember, what's the first step to graphing an inequality in two variables? Remember, you take that inequality symbol and you make it equals, right? You turn this into a line, and we graph the line first. How do we do that? Make a little table. Pick some easy values to plug in. It turns out, actually, if I choose x is 0, I mean, that's fine, but I'm going to get a fraction if I do that. So I think, actually, y is 0 would be good, right? If I choose y is 0, then I'm going to get x plus 4 times 0 is equal to 5. So that means x is equal to 5. So that's 1 point, 5, 0. And then maybe if I choose, it looks like if I choose x equals 1 would be good. Or y equals 1. Actually, let me do y is 1. Y is 1. So I'm going to get x plus 4 times 1 is equal to 5. But then if we subtract, so this is x plus 4 is equal to 5. If I subtract 4, I'm going to get x is equal to 1. Right? So 1, 1 is definitely also a point. So let me plot these 2 points. So I have 5, 0. So I move to the right 5 and nothing up on the y. So right here to stay on the axis. And then 1, 1 is right here. So this line is going to look like this. And should I draw it dashed or solid? Well, because of the equals here, right, I draw it solid. So something like this. Okay, pick a test point, any point that doesn't lie in the line. But what should you use if it's available? You should use 0, 0 because it's easy to plug in 0, 0. So I'm going to pick that as my test point, right, 0, 0. So now I go to the inequality, and where I have an x, I plug in 0. Where I have a y, I plug in 0. And if I work this out, I'm going to get 0 is greater than or equal to 5. Is that true or false? Well, that's false. So since I picked this side and I got false, then I know that the opposite side is the side that gets shaded. So this side is the side that should be shaded. This side contains all the solutions, right? All these points are solutions to that inequality. So the answer to 10 should be B. So this should be B. Okay, 11. So you're given a system, right, of 2 linear equations and 2 variables, 2 unknowns. And you're asked to solve it by using substitution. Okay, so remember the first step to substitution is to solve for one of the equations right? Solve for one of the variables in one of the equations. And you should pick the easiest one. So in this case, see how the x is sort of like by itself in the first equation? So I'm going to choose the first equation. I'm going to solve it for x. So let me just write down the first equation again. How do I solve it for x? Well, if I subtract 2y from both sides, then I'm going to get x is equal to negative 2y minus 4. Great. So that's my first step. Now the next step, here's where the substitution comes in. I'm going to take that expression for x, and I'm going to go to the second equation, and where I have an x, I'm going to plug in that expression. So I go to the second equation, negative 2, and now where I have x, I'm going to put in negative 2y minus 4 plus 3y equals negative 6. Now I have an equation just in terms of y, which I can solve, okay? So let's solve this for y now. So I will multiply and distribute in at negative 2. So I have 4y, right? Negative 2 times negative 2 is positive 4y. Negative 2 times negative 4 is plus 8. Plus 3y is equal to negative 6. Combine like terms. Well, 4y plus 3y is 7y. Plus 8 is equal to negative 6. And then if I subtract 8 from both sides, I'm going to get 7y is equal to negative 14. And then finally, if I divide by 7, right, I get y is equal to negative 2. So that I'm half done, right? I have the y. How do I go back and find the x? I plug it into one of the original equations, but probably the easiest equation to plug it into is the one I already rearranged, right? I solve for probably this one where I solve for x. So I'll go back in and plug y equals negative 2 into that equation. So I have x equals negative 2 times negative 2 minus 4. What's negative 2 times negative 2? That's positive 4. And then what's 4 minus 4? 0, right? So it turns out x is equal to 0. So therefore, my solution as an ordered pair as a point is 0, comma, negative 2. That would be my solution. So let's see. In this case, it looks like it's A, right? It would be the correct answer. So it should be A. Okay, another system of equations, number 12, but they want us to solve it using elimination, right? Which is, you could also call the addition method. So negative 7x minus 6y equals 38, and then negative 5x minus 2y is equal to 18. Okay, so first of all, it's set up, right, for elimination. Remember, you have to line up the x's, line up the y's, and on the right-hand side, line up the constants. So it's already set up. We could eliminate the x's, but that's more complicated because then I probably want remember you want your coefficients to be equal but opposite in sign so that you can get rid of them. And since I have a negative 7 and a negative 5, I probably want one of them to be a negative 35 and the other to be a positive 35. But that means multiplying both equations by a particular value to make them negative 35 and positive 35. Probably it's just easier to eliminate the y's, right? Because here I have a negative 6 and a negative 2. Well, I could leave that negative 6, right? I could leave that alone in the first equation. What would I want to make my second equation, the coefficient of the y, to be? A positive 6, right? And then I can eliminate the y's. Well, how do I make that a positive 6 if I have a negative 2? I would need to multiply it by negative 3. So I'm going to first correct that second equation. I'm going to multiply both sides by negative 3. Okay, so I need to distribute the negative 3. So negative 3 times negative 5x is positive 15x. Negative 3 times negative 2y is plus 6y. Again, we did that on purpose, right, to get a plus 6y there. And then negative 3 times 18 is negative... what is that, 54, I guess, right? So negative 54. So now let me write down the first equation again. Doesn't matter what order you write these in, so I'll just write it below. and then add. Okay, so now if I add, well, the y's are gone by design. 15x minus 7x is 8x. Negative 54 plus 38 is negative, looks like negative 16, right? Then divide by 8, divide by 8. So it looks like x is equal to negative 2. So again, I'm half done, right? I have x as negative 2. And then when I go back and find y, so it doesn't really matter which one I use. I'll just plug it into the second one. So I go back to one of these original equations, right? I'm just going to choose to use this one, the second one. And where I have an x, I plug in negative 2, and I solve it for y. Okay, so I have negative 5. Let me write down again. Negative 5x minus 2y is equal to 18. So negative 5 times negative 2 minus 2y is equal to 18. Well, this is 10, right? Minus 2y is equal to 18. I'll subtract 10. So negative 2y is equal to, it's going to be 8. And then finally divide by negative 2. So y is equal to negative 4. So my solution as an ordered pair would be negative 2, that's my x, and then negative 4 is my y. So that would be the answer. It looks like it's D in this case. Okay, let's see. 13. So this one says, at a local zoo, adult visitors pay $3 and children pay $1. On one day, the zoo collected a total of $720. If the zoo had 420 visitors that day, how many adults and how many children visited? Okay, so remember, the way to start this is create variable names, right? We want the number of adults to we want some variable to represent the number of adults, some variable to represent the number of children. You could use x and y, but in this case, it'll be probably more meaningful if we say like A is the number of adults, and then maybe C is the number of children. Okay, so one thing we know is that the total number of visitors is 420. That means the number of adults, A, plus the number of children, C, has to equal 420. Okay, so that's our first equation that involves A and C. The second equation is going to involve the amount of money that was collected. Now, each adult paid $3, so the total amount of money collected from the adults must be $3 per adult, times A, right, times the number of adults. That will give us the total amount of money collected from the adults. Each child paid $1, so this is plus $1 times the number of children. And then that's got to equal, let's see, it's 720 in this case, right? The total amount of money that was collected. Okay, so this is really set up to use elimination. Let's use elimination. Let's start by eliminating the C. We could do either, but the C. So since I have, remember this is really a plus 1, right? Since I have 1 and 1, I want to make one of them a negative 1. So maybe I'll make the first one a negative 1. So I'll multiply that first equation by negative 1, both sides. Therefore, the coefficient of the C will be a negative 1. Okay, so if I distribute a negative 1, I have negative A minus C is equal to negative 420. I'll write down the second equation again. And now add them together, right? So negative A plus 3A is 2A. Negative C plus C is gone by design. And then negative 420 plus 720 is 300, right? Now if I divide by 2, I'm going to find that A, I'm running out of room here, is equal to 150. So there's 150 adults. And then to figure out the number of children, I just need to plug this back into one of the original equations. In this case, definitely the first one is easier to plug into, right? So I have A plus C is equal to 420. A I know is 150. So now I need to subtract 150 from both sides to isolate the C. So C is going to be 420 minus 150, which is what? 270 in this case? So therefore, there's 150 adults and 270 children, right? And we're done. So it looks like C is the correct answer. Okay, 14. Actually, it looks like the rest of this is chapter 5 stuff. So simplify using the product rule if possible. Okay, so W to the 6 times W cubed times W squared. So remember, if we multiply a bunch of powers together and they have the same base, we keep the base, so W, and we add the exponents. So 6 plus 3 is 9 plus 2 is 11. So this is W to the 11th, which should be C in this case. (15) We have x to the negative 2 over y to negative 3, and then z to negative 6. And we want to rewrite it so that we only have positive exponents. Well, the easy way to think about this is, right, if I move that one of those powers, right, those variables, from numerator to denominator, or vice versa, from denominator to numerator, I'm going to switch the sign of the exponent. So if I move the x to negative 2 to the denominator, it becomes x to the positive 2, right, x squared. And then if I take the two variables in the denominator and move them to the numerator, I'm going to get y cubed z to the 6. Because again, I'm going to change the sign of the exponent. And that's exactly what I want. So that would be my answer. So in this case, it looks like it's A. Okay, 16. We're given a number in standard notation, and we want to put it in scientific notation. It looks like there's 4 zeros here, and then 4, 2, 0, 9. Okay, so remember, what do I want to do? Well, I'm going to have to move that decimal point so it's in between the 4 and the 2, right? Because I want a number that's greater than or equal to 1 and less than 10. Or the other way to think about it is you want a number where you have a digit and then a decimal point. So I need to move this 1, 2, 3, 4, 5 places to the right. And if I move 5 places to the right, what do I do with the exponent here? I have to subtract 5. You can think of it as starting off at 0, right? When it's just a regular number, so you need to subtract 5, right? It's a very small number. It's the other way to kind of double check yourself. It makes sense I get 10 to the negative 5 because I know I originally had a very small number. So this should be D in this case. Okay, 17. Write the polynomial in descending order and identify its degree. Okay, so this is how they originally give it. Negative 8x plus 4 plus 6x squared. So descending order just means write the terms with the highest exponent first and then decrease from there. So I need to write the 6x squared term first, then the negative 8x to the 1 right second, and then the constant last. Remember, you can think of that as x to the times 4 times x to the 0 if you want. But just think of the constant's got to go last when you do descending order. And then the degree of that polynomial is going to be the degree of the leading term, right? The degree of the highest term, which in this case is 2, right? You just have to look at the highest exponent. So this is a second degree polynomial. So it looks like the correct answer is going to be D in this case. Okay, 18. Remove the parentheses and simplify if possible. Okay, So they give us two polynomials to add together. So 10n plus 5n to the 6th plus 8n cubed. And I want to subtract negative 13n cubed. By the way, it looks like some of these questions are duplicates of previous practice sheets, but that's okay. It doesn't hurt to go over them again. Minus 5n. Okay, so for the first polynomial, since I have a 1 in front of the parentheses, I can just remove the parentheses, right? It's not going to affect it. It's not going to change any of the signs. So I'm just going to do that. Remove the parentheses. For the second one, you have to be careful. The way to think about it is you first want to distribute in this negative 1. Right? It's going to change all the signs. So this becomes a positive 13n cubed, a negative 7n to the 6th, and a plus 5n. Now we're just going to combine like terms, and we'll write it in descending order. So I'll start with the largest terms, which is n to the 6th, I guess. So 5 minus 7 is negative 2, right, n to the 6th. Then I have 8n cubed plus 13n cubed, so 8 plus 13 is what, 21 n cubed. And then finally, 10n plus 5n is 15n. And that would be my answer. So it looks like in this case, it's going to be B. Okay, 19. A minus 1 squared. Okay, so remember, there's two ways you could do this, right? You could use that special product rule, which says if you have a minus b squared, this is going to be a squared minus 2ab plus b squared. So in this case, our 7a is kind of like a. Maybe we should call it something different, but I'll call it like large A, and then 1 is like our large B. Okay, so if I use this special product rule, the answer has got to be large A squared, so that's 7a squared, minus 2 times 7a times b, which is 1, and then plus 1 squared, right? So 7a squared is the same as 49a squared. Negative 2 times 7 times 1 is negative 14. I still have an a there. And then 1 squared is 1, so plus 1. So if you like to use these formulas and you memorize that formula, it is a quick way of doing it, but you don't have to do it that way, okay? The other way you could do this, let's say you forgot that formula. So remember, you could just do this, right? You could say, well, I know that 7a minus 1 squared is the same as 7a minus 1 times itself. So let me just multiply this out, right? Or FOIL it out. So I have 7a times 7a. That's 49a squared. I have 7a times negative 1. That's minus 7a. I have another negative 1 times 7a. It's another negative 7a. And then negative 1 times negative 1 is plus 1. And then if you combine the a's, right, negative 7 minus another 7 is negative 14a plus 1. And you'll get exactly the same thing, right? So you can do it either way. It's totally up to you. Choose whatever way you feel more comfortable with. So in this case, the answer should be, I guess B is the correct answer. Okay, and then the last one. Let me go to a new page again. Oh, it looks like we've done this too. I recognize a lot of these problems from before. So negative 35x to the 5th minus 21x to the 4th minus 28x cubed all over negative 7x to the 4th. So remember, rewrite this, right? I can write this as negative 35x to the 5th over negative 7x to the 4th plus negative 21x to the 4th over negative 7x to the 4th plus negative 28x x cubed over negative 7x to the fourth. Now, if I divide these monomials, right, for each term, well, negative 35 divided by negative 7 is positive 5. X to the fifth divided by x to the fourth is x to the 5 minus 4, but that's 1, so I just write it as 5x. Negative 21 over negative 7 is positive 3, right? X to the fourth over x to the fourth is just 1, right? These cancel, or you get x to the 0, which you could also write as 1. And then plus negative 28 over negative 7 is positive 4, and then x to the third divided by x to the fourth is x to the 3 minus 4, which is x to the negative 1. But then we wouldn't want to leave it with a negative exponent, so then we'd write that last term. So the 4 can stay in numerator, but then the x would go to the denominator as the x to the positive 1, right? So then that would be C. C would be the correct answer for that last one. Great. So really that's it for the course. Hopefully you guys are doing well on My Open Math. All right. Great. Thanks.